Every logarithm, unless it's been transformed, will always have a point right there on the horizontal axis. It'll be 1 unit away to the right of the origin. It'll lie on the horizontal axis. Every single logarithm will have that. The next point that you run across, this is log base 3, is 3 units away from the origin on x and 1 unit above. And they always do that. That's how logarithms behave. Because if you do log base 3 of 3, what's the return value? Log base 3 of 3, 1. That's why it's there. The reason I mentioned some stuff here about being no units above and 1 unit above is because this number out here. You did something like this in your notes yesterday. Do you remember, yesterday you had a problem that had a 6 in it. What'd that do? Back to your notes. You got 6 over something. What'd that 6 do? Multiply y by 6. You'd know that if you had notes there, Jordan. Multiply y by 6. Y is just another thing called height. Y is height, that's all it is. Got a big leap of faith to make. Y is height, y goes up and down, doesn't it? So the reality is you're just going to multiply the height here, and I don't know why I wrote 6, probably because I'm tired, not by 6, by 3. Every one of you should understand what x minus 2 does. Right, 2. And every last one of you should understand what plus 3 does. Up 3. If you show them, it makes this a little easier to do. You go right 2, and you go up 3. This little point right here is the easiest thing to move. You're literally supposed to move it right 2 and what? Up 3. That's all you're supposed to do. It was right here, wasn't it? You go right 2, you'd be right there, and then up 3. Right on the horizontal axis. How many units away from the new origin? 1, just like the original. The other one's a little bit harder. That 3 out there is affecting it. The 3 multiplies the height, and this thing didn't have any height above the axis, did it? This one does. It was 1 unit above the horizontal axis. After it gets moved, how many units will it be above the horizontal axis? No. 3. Because the height is now 3. So if I just do the whole right 2 and up 3, I would be here. If I go right 2 more, 1, 2, I'd be there. And I was 1 unit above, so now I'd be 4 up. I'd be right there. But the problem is that didn't change the height of the function, did it? So instead of being 1 unit above the horizontal axis, what do you have to be? 3. You're going to need to go up 2 more units to do that. It ends up being right there. I know that's rough for some kids. I get it. I do get it. But that's the easiest way I know to do a transformation. So that's a lot like one of the ones on the back on the graphing quiz tomorrow. If you can't do it, so be it. Looks like an R, that's why I drew an R. That's what logarithms look like. But you're supposed to move 2 points. Not just 1, but 2 points. That's transformation of a logarithm graph. What's next? Some from yesterday. Also not your notes, you might add it back in. Thankfully, that's not on tomorrow's graphing quiz, but it'll probably be on the next one. Mom is, though. The mom of that function's on your graphing quiz. You won't be able to cheat with a calculator. Sorry. Mom has 2 key points. By the way, mom is 1 over x. She has two key points. Where are they? -1, -1, and +1, 1. Right? Usually I can do the shapes with my arms, but I can't do these. That's the left side of the graph. That's the right side of the graph. That's mom. What kind of shifts happen to mom?
Up 4, or sorry, right 4, left 4.
Left 4. And? Down 3. Everybody can do that. 1, 2, 3, 4. Down 3. You'd be really tempted just to redraw mom there, and it would actually look pretty close. It would look really close if you just redrew mom there. It would. Every time we've talked about functions like this, I don't care what it was. Maybe it was something like y equals 3 absolute values of x something. That number out front has kind of been what? It's kind of been slope. It's always been kind of slope. It's even kind of slope here. It doesn't quite work with logarithms. I wish it did, but it doesn't with logarithms. But it works for this graph. It's kind of slope. You look at mom was 1 over x. To get to that point on mom, what'd you rise? 1. What'd you run? My God, there's a 1 there, isn't there? Start looking at the child, you can put anything in the world over a 1. That's how you find the points on the child. You rise 5 from the new origin and run what? 1. If I rise 5 from -3, I'd be at 2. If I run 1, I'd be right there. That's one of the points on the kid. Then you got to think about that other guy over there. It's kind of like absolute value went both ways. Remember that? This does the same thing. You're not going to be 1 unit below the horizontal axis. You're going to be how many units below the horizontal axis? 5. So you're going to have to count down 5 units. And you're going to be 1 to the left, which you got right in there. That, boys and girls, is the easiest way I know to graph that particular type of function. Make sure you don't cross your horizontal asymptote or your vertical asymptote, because they are not possible to cross for that function. And that is your refresher of everything I tried to teach you yesterday. Plus something will maybe help you in your graph. I don't know. We'll see. But y'all are going to complain about this class when you can't memorize 9 mom functions. God, this is as far as we got. Hours of a numerator when analyzing a graph. This is something that's really old. This is really old skill. I'm going to draw a little freehand graph here, something that would be on your basics quizzes. That guy right there. That looks like something on the basics quiz, doesn't it? Some of you don't even know. That's on the basics quiz. Right here is the graph crossing or touching. That's a crossing. If you cross the x-axis, the 0 happens how many times? Once. Don't be sitting there screaming, I don't understand. It's called memorization. Odd multiplicity. It happens at least once, and that'd be 3, 5, whatever. Emphasis on the minimum, which is 1. That's a touch. Starts with a T. What else starts with a T? Twice. So if you touch the x-axis, how many times does 0 happen? At least twice. It's going to be an even number. It could be 2, 4, 6, 8. Emphasis placed on 2. That's something old, hopefully. This is actually titled Powers of the Numerator. I mean, you're dealing with fractional things in this particular section, aren't you? So while we're at this thing, let's do something old. Let's say that this point right here is at negative 2, 0, and that point is at 5, 0. Why not? Something old. Since I'm dealing with powers of the numerator, and I want it to be a fractional function, I can just throw it over to number 1. That makes it a fraction, doesn't it? The zeros create the factors of the numerator. That's what they do. Because 0 divided by anything, so what? 0. Zeros happen in the numerator. If you have a 0 at negative 2, what's the factor that creates it? If you have a 0 at negative 2, what's the factor that makes it? No. X plus 2, kids. Factors. You've done that. If you have a 0 at 5, what's the factor that creates it? X minus 5. We need to think about multiplicity. Negative 2 was a crossing. What's its exponent? 1. 5 was a touch. What's its exponent? 2. So that's old stuff. That's really old stuff. That's before Christmas break, isn't it? Really old stuff. There's your review on that. New stuff. Powers of the denominator. These notes don't explicitly say it, but the factors of the denominator are created by asymptotes. Specific asymptotes. Vertical asymptotes. Factors of the denominator are created by vertical asymptotes. Again, that says factors of the denominator are created by vertical asymptotes. Just as there's a multiplicity for zeros, there's a multiplicity for asymptotes. Fun stuff, isn't it? Don't hate me. Hate algebra 2. My high school teachers all taught to the slowest kids in the class. Who'd that harm? My high school teachers all taught to the slowest kids in the class. Who'd that harm? Me. Calculus 1 was tough for me. Do you know why? Because I hadn't seen what I was supposed to see. I don't teach the bottom. Figure it out. Determine the power of the factor of the denominator that creates the vertical asymptote. You have to remember more stuff. This slide is dealing with behavior near the asymptotes where things go the opposite direction. Kind of a big deal. Graph. Running opposite direction. Emphasis on that O. One side of the asymptote, the graph shoots up to positive infinity, the other side it shoots to negative infinity, or vice versa, negative infinity, positive infinity. I use the word opposite direction. That's important because if one side shoots to positive infinity and the other to negative infinity, or vice versa, along the vertical asymptote, the factor of the denominator is odd. Odd starts with O, just like opposite, doesn't it? If you're odd, what's the smallest thing you can do?
Milbrath,
Yes, ma'am.
can you please send me Turbo to the office for a moment, please?
They'll be up there. More stuff. Rain drain already? It says in situations where the graph shoots to positive infinity on one side and negative infinity on the other side of the vertical asymptote, which is what those graphs are representing, the factor of the denominator is going to be an odd. It's going to happen at least one time. I guess it should say odd power, maybe. That's what happens if the graph is behaving opposite of each other. So the next page is going to talk about what happens when the graph behaves the same on both sides of the asymptote. That side rises to infinity. That side rises to infinity. Or vice versa, that side falls to infinity, as does the other side. So the behavior near the asymptotes is the same. On the right it's high, on the left it's high. Or on the right it's low, on the left it's low. If opposite is an odd power, what's the same? Even. That's not usually the case to make. What's the smallest even number you know? 2, at least twice. Kind of like crossing and touching, but kind of not.
I don't get what you mean when the graph shoots.
What's happening right here to the graph? Where's it going? Positive infinity, right? Is that going to rise for all of its life?
Do you mean like the x-axis?
The y values. Both sides, the graph is going where? There. Behaving the same. That's going to be an even power. Let's make a little bitty problem out of this thing. Let's just focus on powers of the denominator. Let's make a rational function up. We're not going to worry about what the zeros are right now. That's for the next slide. And this is about powers of the denominator, not powers of the numerator. All I'm caring about is what's in the bottom. That's it. I'm going to make up some arbitrary numbers for these asymptotes. Say that one's at -3 and the other one's at 2. This is just like zeros and factors, kids. That's all it is. If there happens to be a vertical asymptote at x equals -3, what's the factor that created it? Some of y'all, that'll make sense. Because if x was -3, what would you be dividing by? If x was -3, what would that thing be dividing by? If x was -3, what would that thing be dividing by? 0. Your notes explicitly say that asymptotes happen when you divide by what? 0. If x is 2, what's the factor that makes it? X minus 2. No, it's 2. It's going to be x minus. Always change sign in the parentheses. Because if x was 2, you'd be dividing by 0, and bam, an asymptote. You guys just forgot yesterday when you looked at your notes. It's all on you, not me. What's happening here? How's the graph behaving near that asymptote? Both up. Same thing's going on, even odd multiplicity. Even. So at -3, created by the factor x plus 3, we have a 2. On the other guy, the right-hand side's going down, the left-hand side's going up. That's opposite direction, isn't it? Even or odd? Odd. That's how you write denominators, by looking at graphs. Again, I'm doing this for you college-bound kids because a dual enrollment teacher told me that it kind of sucked this year when she did rational graphs. I tried to throw it out last year. I did. Turns out I shouldn't have. Back. All right, analyze this graph. Ultimate goal here is to write an equation. Do you see any zeros? Zeros are where you cross what axis? X-axis. There's going to be one here. There's going to be one right there. What are your two zeros? -3 and 2. While I'm here, I may as well talk about their multiplicity. We just took notes on multiplicity. Are those crosses or touch? They're both crosses. And if you cross, what's your multiplicity? 1 crosses. Some of y'all, and I know who you are, completely missed this on the basics quiz, and you're still not taking notes. It's still apparently my fault. Horizontal asymptotes are kind of funny. When you hear the word asymptote, what do you think? You think it's something you can't cross, then you can't be. Horizontal asymptote is kind of a contradictory to the word asymptote, but the horizontal asymptote may be crossed. You can go back and look at some old notes because I defined it this way with y'all. Near the origin. This one has one. It's right here. In algebra 2, it'll always be right there, I think. Boy, it's hard to make these things up by hand. What's the equation of the horizontal asymptote? Y equals 0. Again, you can cross a horizontal asymptote. It's the vertical ones that can never be crossed. You guys know why the worst section in the ACT is the science section? Tables and graphs. Has nothing to do with being last. Tables and graphs. I guarantee you 1 in 3 kids, they see a table, they get anxious. Guaranteed. I've done this a long time. If you get anxious, you just turn off immediately. That's what happens. Some kids could not interpret a graph to save their life. There's something going on right there. You're never getting to be that x value of 2, are you? -2, thank you. Here's another one. Where's the other one at? X equals 4 is the other one. There's one here at x equals -2, and there's another one at x equals 4. There's your vertical asymptotes. Those are the things that x actually can't be. It's kind of funny we say x is. That's because you're writing equations in lines that aren't there. But those are also the things that x cannot be. So what's your domain?
X does not equal.
All values of x such that x is not -2 or 4. I want to take a stab at range. My guess is Ashley focused on the middle of the graph. So what you focused on, Ashley? Oh, this is the only piece that matters. That falls forever, doesn't it? Does it rise forever? Did I ever pick up my pencil? Nope. There's no gaps. So yeah, if you like interval form, it's definitely negative thing, positive thing. But I hate for you to take the ACT and not completely understand the set builder either. How do you write that using set builder?
Y is everything real.
Y is everything of the real. Yeah. All values of y such that y is an element of the real. We did all the easy stuff. Nice time to write the equation.
Is it 1 over?
No, this is not 1 over. Chris just asked, is it 1 over? What's 1 over look like? It's 1 over x. What's it look like? It's like that and that, right? Or I did that wrong. It's like that and that. That doesn't look like that. I guarantee you if it's that ugly, it's a fraction. Any graph that is that hideous is a fraction. For one, it's got vertical asymptotes. This would be a fractional graph. Some of you guys know your forms, some of you don't. Let's do this. None of that. Every form for any equation always has a certain letter in it that you have to find. What is it? A. It was even in your notes that I gave you yesterday. It's right there. That thing has an A, doesn't it? All of them have an A. Every equation has that letter A in there. That represents your leading coefficient. So when we start writing this equation, we got to have the letter A. And where do you think it belongs, numerator or denominator? Numerator. Why is A over something? I already marked off the zeros, but you have them on your piece of paper. You had a 0 at -3, didn't you? What's the factor that creates that? X plus 3. Was it a crossing or a touching? So what was its multiplicity? 1. You had a 0 at 2. What's the factor that made it? Why am I putting them in the numerator? Because zeros go in the numerator, asymptotes go in the denominator. That works. You have an asymptote back there at -2. What's the factor that makes it? Plus 2. You have an asymptote at 4. What's the factor? It's -4. Multiplicity needs to be talked about. At 2, the graph is going up and the graph is going down. Opposite. What's the multiplicity? 1, because it's odd. At 4, the graph is up, both sides of the asymptote. 2, because it's even. Same thing on both sides. That's really how hard it is. It's not that bad. What are we missing? A, which means we need a point. Anybody who's done anything in this class, that means you need a point. And I forgot to plot one on this when I did it. So we're going to say that's 0, 1/2. We're going to see what we get. What good does knowing that point do you?
Fill in an X and a Y.
Yeah, everywhere you see a Y, you're a what? And everywhere you see an X, you're a 0. Don't just sit there with your thumb up your butt, try and figure out what's going on. Try and figure out what these easy things are. What is this stuff that's attached to A? I mean, you've got calculators. Can't do it in your head, use a calculator. Figure out what everything attached to A is. That's what you got to know. Otherwise, you won't be able to find it. I type it all in a calculator, kids. If you don't know what 0 plus 3 is, TI-84 will do that for you. It will, won't it? It will. I saw a kid do that once. She dropped out the very next day. True story. It's kind of sad, but understandable. But I know I do have kids that can't add. It's just part of it. You know, when I was doing this in 4th period, I waited 5 minutes for them to give me an answer. So eventually I just typed in a TI-84 exactly what we wanted to know, which is that. Isn't it? You know how you get to pull that up, make it look like that? You go math where? Num and over D, numerator over denominator. I don't know why y'all aren't pushing buttons. I don't get it. Like, seriously, what do you want me to do? Pass you because I like you? How I feel about you has nothing to do with the grade I give you. Nothing. I am not biased. I actually don't even look at whose test I'm grading until after I've graded it. You know why I do that? To be unbiased. Plain and simple. To be unbiased. I don't look. Worst thing I could ever do would be feel sorry for you. Negative 3/16. That's what's attached to A. Attached to A is a negative 3/16. What'd you get? 72/16? No, I haven't, something, I don't remember what it was. Maybe you got a decimal, I don't know. No, that's what it's attached to. Now that you know what's attached to A, what do you do with it? Hey, you're pushing buttons. If I was sitting here with a TI-84 in front of myself, I would literally do 1/2 divided by arrow up. That's what I do. And math frac. Negative 8/3 is your A value. Kids, if you can't do the math, I wish you'd play along with the calculator, because I show you constantly how to use them. Although I know some kids are intimidated by the sheer number of buttons that thing has. That's a lot. One more thing, because we ain't done with this. We're not even done when we just throw it in, put it in position. Somebody, and I agree with them wholeheartedly, decided that it was kind of ugly to have a fraction with a fraction in it. It is kind of ugly. You got a fraction, and then there's another fraction inside that fraction. It's called a nested fraction. It's really considered ugly. Where's division happen? Denominator. What's 8 being divided by? So where can you put the 3? On the bottom. That's a whole lot better looking answer. I think it looks better. I didn't get good at math until I learned how you were supposed to write answers. I could always come up with a decimal. That was easy. I didn't get good at it until I learned how you're supposed to write it. There you go. That's what she's supposed to look like. Anybody any questions on that thing? No? It's a lot. I get it. Better to see it now than when you show up in an upper level math course. All right, last one I get to do with you. Analyze another graph. The zeros we worry about on the next page is the same graph. Where's its horizontal asymptote?
Like this one.
Remember, it's okay to cross that one. You can kind of get an idea that on the right it's hovering right above. On the left, doesn't it look like it's approaching? Y equals 0. How many vertical asymptotes you see? 2. Where's one of them at?
X equals 1.
Look at the scale.
I can see the scale. I can't see the scale.
It takes 5 blocks to make a 10.
So X equals 2.
One of them's at X equals 2. What about the other one?
4.
I saw Mackie answer that one first. He wasn't loud, but he was mouthing. What you said, wasn't it? Some kids you just have to read. Some kids won't say anything, but they just smooth the rest. All right, that's easy. What's this thing's domain?
Doesn't equal to 4.
There you go. We write those asymptotes X is, but the reality is that's what you can't be. All values of X such that X is not negative 4 or 2. I don't count all for this, but you're supposed to put those things in increasing order. You're supposed to. You're not supposed to say 2 comma negative 4 because that's not increasing. That's like alphabetical order. Range, if you follow that line straight through the middle. There you go. That's not so bad. How do you write that in set builder?
Why is everything such that probably is an element of a real?
Yeah. The ACT is more likely to use set builder than interval. I'm not saying they all want to use interval notation, but the most more likely to mention set builder. We'll even see some funny things like this. You might see something like this. Oh, how do they do that? That, what does that mean?
Actually, isn't zero.
That's null, which means nothing.
X isn't.
It means x is nothing. Isn't that kind of funny? I've seen that on a couple of tests. X is nothing. Symbol for null, which is nothing.
If there's no X in there, it shouldn't be a Y.
It comes up with solutions, solution sets. If there's no answer, they'll use notation like that. X is nothing. All right, so this is the same thing, but now you get to write the graph. Where are your zeros at?
X equals 6.
Okay, Chris obviously knows what's going on. Anybody besides Chris care to share the multiplicity of -2? 1. It's crossing. Anybody care to share the multiplicity of the 0 and 6? 2. That's a touch. That's a big deal because now we can write the factors of the numerator, can't we? If x is -2, what's the factor? If x is 6, what's the factor? With an exponent of? Don't forget about the letter A, kids. It's there. Where do we get the factors of the denominator?
Vertical asymptote.
From your asymptotes, your vertical asymptotes. You had one at -4. What's the factor?
X plus 4.
That one is behaving on the left side of the asymptote going high, on the right-hand side going low. Opposite direction, so it's the exponent. 1. You also had an asymptote right here at 2. What's the factor? That one's a square, because both sides the graph is rising. Same direction. Now the easy part. And I even gave you the point this time, didn't have to make something up. Everywhere you see y, what do you get to be? Nope. Dyslexia, be careful about that. Order pairs go x, y. 4.5 is y, and everywhere you see an x, 0. You can't do it in your head, push the buttons, use that fraction key. Go math, num. Hit that up arrow one time until you see n over d. Again, that was math. Scroll right to num, which is how you feel. That's how I feel today. Hit that up arrow. Choose n over d. Or don't. A lot of kids are going to go with don't. That's how you get to it. That was it right there, wasn't it? Probably didn't have any calculator, by the way. That's what good money if you push the up arrow a couple of times. These things remember everything. You've got 9/2. That's what's attached to A. What's 9/2 is decimal? At least one kid will tell me, since there's a 4.5 attached to A, that A is 4.5. A is 1. That was a lot of work for 1, which is understood. There's your equation. That's all I got for you today. Thank God. Maybe next year we can get A in college algebra. Or B.
I checked out at the beginning.
I can tell. That's what I get asked all day long.